Salutations, celestial sightseers. I'm David Fuller. Welcome to Eyes on the Sky. What's up this week? Well, on November 11th, there is a very rare but regularly enough occurring event that we can actually see it several times in our lifetimes, depending on the timing. And for much of North and South America, and including even over in Europe and the Middle East and Africa, there is an event that is possible to be seen provided that you have some clear skies, and that is the transit of Mercury. The last one occurred in 2016, although the next one will not occur until 2032, and that one really is centered on Africa. So if you're in North America, this is your chance to check this out. Now, what's going to happen is, let me actually show you the map of who can see what and when. This is the map of what's visible and what you either will see full transit or partial transit. So the eastern part of North America, basically not quite from the Mississippi over to the east, a little east of the Mississippi, because I here in Chicago will just barely not be able to see the whole thing. To the east, we'll be able to see the entire transit. And then the very western edge of Africa and all of South America. We'll be able to see all of it. However, if you are west of that line, then you will have to see it sometime after the sun rises where you are. And if you are to the east of there, you will be able to see the transit in progress as the sun sets. So you won't get to see it as it finishes, but you will at least be able to see it when it starts. So that includes really, as you can see, the Middle East and Europe and Africa. So that's what we have available for a lot of the world, which is fortunate because that's a lot of my viewers. I know I've got some folks over in India who will unfortunately miss it. But you can watch online. There are going to be a number of live streaming feeds for that, so do some searches probably on Friday or Saturday, the 9th and 10th, to see who's going to be live streaming that. I probably will not be, just because I don't think I'm going to have a good enough internet connection to be able to do that. But if I have the opportunity to do a little bit, then I will try to. When we watch this transit occurring, now I'm just going to show you from my location, the sun will rise, and the transit itself lasts for about 5.5 hours or so. And so that means for me, looking here at just after 6:30 in the morning, here's the sun as it would be rising. And if you look, if we bring that up just a little bit like this, and then kind of zoom in, you can see how, at least on the stellarium view, it shows a number of sunspots. The sun does not have a lot of sunspots right now. It has pretty much no sunspots. It's been quiet the last couple of years, but right over here, this little teeny dot, we'll bring this up just a little bit more and you can see that better, and you can see how that dot is actually moving pretty substantially across the face of the sun, and we can kind of speed that across in a couple hours like that. And I will have until about 11:56 in the morning to be able to catch the transit all the way across. So there we go at 11:56. That's what's for me will be the third contact, right there where the planet is just about ready to touch the limb of the sun. I can go actually just a couple seconds forward into that. And what we want to, if you want to do some real science here, if you have a pretty decent zoom on it, this is probably much more than you'll get in a telescope, but the best you can do, you want to try to time that contact as closely as possible, and then you can actually submit that information. EclipseWise is a website that would take that information, I believe, if I read their information correctly, and would be able to use that information to help us to accurately locate the distance of our sun. It's a useful exercise. But when this happens, when that tangent of the planet meets the tangent of the sun like that, we call that the contact, one of the contacts. So second and third contact are where the edge meets there. Now on the other side of that, you can see, whoops, that's going to happen really fast. The first and fourth contact are actually really difficult to see in white light because you don't really have anything to tell you what's actually happening. Like, where's the planet? You don't necessarily know where exactly it's exiting because there's nothing behind it. But if you happen to have a Lunt or Coronado H alpha telescope, which shows the solar flares. You may have enough of a flare behind where the planet is at the time that it transits that you can actually record either the first or the fourth contact as that's actually occurring, because there may be enough light behind the planet to provide that. And if you have that information, then by all means, definitely do that. So that doesn't take very long. If you notice, that's only about a minute and 40 seconds or so that takes to actually exit the sun, because Mercury is not very big. If I back out a little bit of this so I can actually get the planet itself, you notice that the apparent diameter is about 10 arc seconds across. That's small. So you will need a lot of magnification using a telescope, probably anywhere between at least 50 to 100 times, ideally. If you have one, a mount that will motorize your telescope to follow the sun as the Earth rotates, so you don't have to keep moving it, is going to make things a lot easier for you if you happen to have that available. And also, of course, use a proper solar filter. Please do not try to stack a bunch of Mylar sheets or a bunch of other crazy things that sometimes people do. Use a proper solar filter. If you're not going to use a solar filter, you may use a refractor telescope with an eyepiece, no star diagonal, just a straight through. You may use that to project an image of the transit occurring. I did this with the transit of Venus back in 2012. You can see how I've got there's the dowels that I used to kind of make an extension, and it was about 12 to 14 inches behind where the actual eyepiece was, and I just used some simple duct tape, and I had some screen material that was supposed to be good for like TVs and things, but you could use a white piece of paper, because the image is spread out enough that it won't cause any issues with heat or anything. But Venus was much larger. It has a much larger disk, but Mercury will be much smaller. I'm going to show you the 2016 one. I did not take this photo, but you can see how small Mercury is in comparison to what Venus was. And even if I zoom that in to give you kind of a similar view of what I had with the Venus sun, I mean, Mercury's going to be small, but it'll probably be the only black spot on the sun, because I don't expect there to be really much in the way of any sunspots. So that should make it simpler to be able to locate where the planet is actually going to be crossing. Now, one thing I do want to show you is the timing of when this will be happening. Here's the different times in universal time for the various contacts, and then the point at which it's in the middle of the sun, really. Now these, you will have to use a time converter depending on what your actual location is, but this is when it's going to happen. So as you can see, we've got about 5.5 hours of time to be able to witness this event. So it will take a while. You've got some time to be able to adjust things, once the planet is actually transiting the disk of the sun itself. But do try to see if you can see the planet entering during contact 1, because you don't have a whole lot of time as that enters, and also as it exits. So look for that contact 2 and 3. And one thing that you might notice at that contact 2 and 3 is something called the teardrop effect, where you want to see that tangent where it actually kind of touches in on the surface there, but there's an optical effect that occurs where it sort of looks like it has like a little bridge from the planet over to the disk of the sun. I'm not sure why that occurs, but it does occur. So that's an interesting effect. And if you can capture that using astrophotography of any kind, if you have some ability to be able to do that, then that is an interesting capture for sure. I did not quite get that with my Transit of Venus photos. This one does show kind of that tangent where it's just about there. And I thought that was actually a pretty good capture, considering I had a much lesser cell phone back then, and that was just a cell phone held up to the eyepiece type of photograph. And cell phones have certainly gotten much better in the last 7 years with their camera abilities. So you can even try that. So definitely look for this if you have the ability to do so, if you happen to be in that area where the transit will be visible, and see if you can witness the transit of Mercury for the 2019 transit. That's all for this week. Keep your eyes on the sky. And for this week, hopefully it's just clear skies, because we don't necessarily need lights off or anything, but we do need clarity of the atmosphere in order to be able to see the transit of Mercury.